Let us continue further. The second preparation reaction of carboxylic acid is from acyl chloride and acid anhydride. Okay, first of all we will see from acyl chloride. As we know, the formula of acyl chloride is general formula R C double bond O Cl. Okay, this acyl chloride goes on hydrolysis. Hydrolysis means addition of water. Okay, suppose this water molecule I will written like this, then it will be easy to understand. This Cl and this H will remove the HCl as a byproduct, and this OH will attach on this carbon atom. Okay, and this will form the R C double bond O OH plus the byproduct is HCl. So what will be the statement for this reaction? The acyl chloride on hydrolysis with water gave carboxylic acid. Actually, this method is useful for the preparation of aliphatic as well as aromatic carboxylic acid. Okay, we can prepare any of the acid by this method. Suppose this R I will replace by CH3CH2, ethyl group, C double bond O Cl, ethynyl chloride, HOH. This will remove the HCl, then it will form CH3CH2, C double bond O OH minus HCl is the byproduct. Okay, this is the type of carboxylic acid is aliphatic carboxylic acid. What is name of this? 1, 2, 3. 3 carbon atoms are there, so it is propionic acid. Propionic acid. Okay, let us see one example of aromatic acid. This R I will replace by phenyl C6H5, C double bond O Cl, that is benzoyl chloride, plus HCl, sorry OH. It will prepare byproduct, that is HCl. Then it will form C6H5COOOH, means benzoic acid, and the byproduct is as usual HCl. Okay, this is what the two example we have seen. Now let us prepare the carboxylic acid by using the anhydride. What is the formula of anhydride? R C double bond O O C double bond O R. This is acid anhydride. In general I have written undergoes hydrolysis, then it forms 2 molecules of carboxylic acid. It will form. See here how this OH. Okay, the bond in between oxygen and carbon, this will break. The hydrogen will get attached to this oxygen, and this OH group will attach to the carbon atom. Then it will form RC double bond O OH, that is carboxylic acid. Yes. Then another one is RC double bond O OH. That means in total it forms 2 moles of carboxylic acid. Sorry, RC double bond O OH. It will form the 2 moles of carboxylic acid. In general we have written this reaction. Now one of the example we will solve. We will take the example of acidic anhydride CH3, C double bond O O C double bond O CH3 undergoes hydrolysis with H2O. It forms 2 molecules of acetic acid. Okay, this is the acetic acid. This was the second preparation reaction, that is from acyl chloride and acid anhydride. Now with statement, general reaction and the example, you write it in your notebook. Now the third preparation reaction of carboxylic acid is from ester. Okay, from ester also we can prepare the carboxylic acid. And there is also the same common thing. By hydrolysis we can prepare the carboxylic acid from ester. But here two types of hydrolysis are given. One is the acid hydrolysis and another one is the alkaline hydrolysis. First of all, we will see acid hydrolysis. Ester on acid hydrolysis with in presence of a dilute mineral acid like HCl, H2SO4, it gives corresponding carboxylic acid. Okay, simple statement of this reaction. Now we will see, this is the general molecular formula of ester. It goes on acid hydrolysis. Why it calls acid hydrolysis? Because it takes place in presence of dilute mineral acid. Either we can take here HCl or H2SO4. Okay, and it forms corresponding carboxylic acid. Okay, plus what will be the byproduct? Suppose this HOH water molecule I have written like this, then it will remove the alcohol as a byproduct, that is R-OH, and H will goes on this oxygen atom and it will form the carboxylic acid, and the byproduct is alcohol. Okay, this is the general reaction of acid hydrolysis of ester. Now one example we will see. CH3, CH2, CH2, C double bond O, O, C2H5. What is the name of this? This is ethyl butanoate. Remember, OAT is used for the IUPAC nomenclature of ester. Okay, and the smallest alkyl group, it is considered as a substituent. So 1, 2, 3, 4 carbon atoms, so it is butane. OAT is represent for the C double bond O, and C2H5, that is ethyl, is it considered as the substituents. Then it undergoes acid hydrolysis in presence of dilute mineral acid. See here, I will write here plus HOH. Now this C2H5 and OH, it will form the alcohol C2H5OH, and this one is the CH3, CH2, CH2, C double bond O, OH. This is the butanoic acid. Okay, and always remember which alkyl group contains lowest number of carbon atom, it will form the alcohol. Okay, and which contains the highest number of carbon atom, then it will form the carboxylic acid. So I have taken this example to understand this concept. Now let us see the second preparation reaction of acid under the heading from ester. That we will see the second preparation reaction, that is alkaline hydrolysis of ester. Okay, this is the general molecular formula of ester. This ester reacts with a dilute alkali, that is NaOH. Okay, or we can take here potassium hydroxide 2. Okay, this will goes hydrolysis, then it will form the sodium salt of carboxylic acid like this. Okay, plus ROH. Okay, this OH and this R will form the alcohol, and this Na, it gets attached to the carboxylate ion. Okay, this sodium salt of carboxylic acid again undergoes hydrolysis, that is addition of water, then it will form the corresponding carboxylic acid. Whatever acid you will select, then it will keep the NaOH again as it is. Okay, This is the carboxylic acid. And this is general reaction. The sodium or potassium salt of higher fatty acid, this one, are known as the soaps. Hence, this is the alkaline hydrolysis of ester is called as the saponification. This process is called as the saponification, and this we have seen already in the 11th standard. I think 16th lesson it was. We have seen under that lesson this saponification reaction. We'll solve one example of this. CH3CH2 C double bond O OR plus, I will write NaOH like this, then it will be easy to understand. This OH and this R will remove the alcohol. Here I will write CH3, then it will form CH3OH. Okay, and this is CH3CH2 C double bond O minus Na plus. Okay, now further it goes on hydrolysis. It will form CH3CH2 C double bond OH. Which acid it is? 1, 2, 3, propanoic acid. And the byproduct NaOH. Okay, this is what the example of alkaline hydrolysis, and this is the general reaction. Okay, note down in your notebook.